Hello guys, welcome back again to my YouTube channel. Now we have a question on the board which have been asked in the J Mains this year. The question is already written on the board to save our time to solve this question. Get it? So we have given basically a circuit. Actually, we have given there a Zener diode. This is basically the Zener diode, and the question was asking me there what is the current through this Zener diode. So we want to calculate IZ. I'm assuming here that you know the basic details of this Zener diode. I won't go into the details here, but I will just solve the question. Get it? So we have basically a Zener diode which is always connected in the reverse biased condition. How we know this is connected in the reverse bias condition? Because this is the positive end of the Zener diode, this negative end. So this positive is connected to the negative terminal of the battery, and the negative end of this Zener diode is connected to the positive end of the battery. So this is simply the reverse bias condition, and this Zener diode always work in the Zener breakdown voltage that's given. Get it? So we have applied voltage as 100 volt, and the voltage across this Zener diode, that is basically the Zener breakdown voltage, that is 50 volt. Get it? Zener breakdown or simply reverse breakdown voltage. Now we want to calculate. It was not actually given there, these values were not given there, so we have been asked to calculate the current through the Zener diode. So how will you calculate this current? First you must know the current that's coming from this resistor. Get it? So how will you calculate the current that's flowing through this resistor? It's known as the dropping resistance if you know the basic details of Zener diode when it's connected in the circuit. So we want to calculate the current first, which is flowing through this resistor. From Ohm's law we know that V equals to IR, and if you want to calculate I, that's equal to what? V divided by R. Now we have a question. What is the potential across this resistor? We know the applied voltage is 100 volt, and it's already given the Zener breakdown is 50 volt. So whatever be the voltage across this Zener diode, the rest of the voltage will be dropped across this resistor. Why? Because this resistor is connected in the parallel combination with the Zener diode, so it will be also at 50 volt, because in parallel combination voltage remains same, and the part of this voltage will be dropped across this resistor, so it will be 50 volt. Now let's calculate the current through this resistor. So voltage is now 50 volt divided by what is resistance, that is 100 ohm. So when you calculate this value, it comes out to be 0.05 ampere. It's a simple calculation, and when I calculate it in the milliampere, because the solution was given in milliampere, so in milliamperes it comes out to be 50 milliampere. So the current which is coming from this resistor is 50 milliampere. Now let's calculate first the current across this path. Why? Because if you know the current through this path, you can calculate current across the Zener diode by using the KCL rule, that is the Kirchhoff's current law or Kirchhoff's current rule. Get it? So how will you calculate first? Why I am calculating that? Because we don't know the resistance of the Zener diode. So that for that we have to calculate first the current through this resistance. Get it? Or through this load resistance. So we will again use the formula V equals to IR. But we are writing the voltage across this across this load resistor as VL, and current is simply written as I, and the resistance will be written as RL. So we want to calculate here I. So I will be equal to VL divided by RL. So what is VL? That is 50 volt. What is resistance across this load resistor? That is 2000 ohm. And what will be the value? This value comes out to be 0.025 ampere, and when you convert it into milliampere, it comes out to be 25 milliampere. Now it's a simple question. Now let's use the Kirchhoff's current law at this junction. So we have a point where the part of current is going across this. We have calculated that comes out to be 25 milliampere, and the current coming from this resistor is 50 milliampere, and part of this current is going across this Zener diode. Get it? So we want to calculate that. It's a simple question. If we have 50 milliampere, 25 is going across this path. Get it? So the rest of 25 is going through this Zener diode. So the answer will be, the current through the Zener diode will be 25 milliampere. So we explained it a little bit in a detail. Why? Because some points in this circuit are not known to some students, so that's why we discussed it in detail. So good luck.